All right, so welcome to our project. We are the Electric Pythons, and our project was on heart disease.
So, our motivation was that heart disease is the leading cause of death in the United States and that the costs of healthcare are increasing. So, we wanted to provide people with an easy to use and reliable resource to check whether they are at risk of having heart disease.
A critical part of building the machine learning algorithms was obtaining a data set that contained useful information that we can use as a teaching set for the artificial intelligence. Having accurate predictions is obviously the most important part, so we found and used a data set that contained medical records from people with and without heart disease without missing data. However, we did need to clean the data, so we got rid of outliers of certain variables and introduced standard scaling to control the distribution of data so that we can draw accurate conclusions about certain correlations of the body and whether they're associated with contracting heart disease.
So this right here is a histogram of the various factors that we counted in heart disease. In our data, for one of the charts, for the sex histogram, it shows that females are at a greater risk of contracting heart disease compared to men. Despite there being a lower sample number of females in the data set, the proportion of females affected with heart disease are almost as high as men. We also have a slope histogram, which is near the bottom right. And as the slope levels increases, the amount of people affected by heart disease also increase, showing a possible positive association. For CA, the very bottom right, CA is basically the number of organs that are affected by fluoroscopy, which is a chemical used in medical diagnosis to check up on a patient's organs. So off of that, I hypothesize is that since the people with heart disease have zero major organs affected by fluoroscopy, it could mean that these people don't get their medical checkups to see if they're okay and get the help they need before heart disease strikes.
All right, we ended up using a scattered plot matrix between different factors we thought would be most indicative of, indicative and have correlations between heart disease and such. We colored them to differentiate between people who did and don't have heart disease. So yellow meaning that they do, blue meaning that they don't. And we found some we found some negative correlations between age and THLATch, which is the maximum heart rate. And then what is it? People with higher disease with heart disease tend to be older from what we found.
We're using a heat map made to portray the factors of heart disease because it displays the data in easy to understand way. The color scale told us what factors were correlated with each other and with heart disease, indicating what variables we should focus on. The most important column to look at is the last one, since it indicates the correlation between heart disease and other factors. The most positively correlated variables we found were chest pain and max heart rate.
So our best model was extreme gradient boosting, or EGB, and it's a supervised machine learning program that combines many other models, usually weaker ones, to make its own highly accurate one. It's similar to random forest and decision tree models in the way that each of the models making up EGB makes one big tree model with thousands of trees. EGB converts all categorical data into one hot coding, which basically means it prepares the data for the algorithm by assigning the categories ones and zeros. And the results of the model was that it performed extremely well with a recall score of approximately 0.972, indicating that the model had predicted 3 false negatives out of a total of 108 true positive and false negative values. The confusion matrix below even shows that the model produced no false positives.
Another machine learning model that we used was the random forest classifier, which turned out to be our second most accurate algorithm. What it does is it takes a certain number of decision tree classifiers that operate as an ensemble and uses the mean of the results to improve predictive accuracy. The predictions that occurred the most amount of times becomes the overall prediction for the model.
All right, so for the results, the random forest classifier spat out a recall score of 0.935, and it was able to identify very clearly who had or did not have heart disease correctly. As you can see in the confusion matrix, there were only 6 false positives and 0 false negatives, which is pretty ideal since having or not having heart disease is a very serious thing.
The k-nearest neighbors algorithm is a simple supervised machine learning algorithm that can be used to solve both classification and regression problems. KNN works by finding the distances between the inserted data point and all their examples in the data, selecting the specified number of examples closest to the data point, then classifying the data point among its nearest neighbors.
So as you can see in the confusion matrix above, k-nearest neighbor performed fairly well with a score of 0.94, which is 94% recall. It has 6 false negatives which we could work on and improve because that could be detrimental to a patient's health. But overall, it has 81 true positives and 102 correct false calls.
So ultimately for our results, we narrowed down the most effective model to actually be the extreme gradient boost. And we base that effectiveness on recall, which we've mentioned before. It's just how many false negatives, true positives there are. Well, how many true positives there are compared to how much you could have actually gotten right, which is very important. The extreme gradient boost had a score of 0.9725, and the runner-up models were the k-nearest neighbor and random forest classifier, respectively.
The machine system that we have developed will be critical in allowing a patient to be informed of their health risks and if they should seek medical assistance or not. Since our system is free to use, patients will not need to worry about the medical costs to identify the risk of heart disease, that they can take a preemptive on keeping themselves healthy, getting help before their situation turns fatal. That is our main goal, to inform people about their health without any cost so that they can get the help that they need and understand the factors that go behind heart disease. Our project works to give accurate predictions most of the time, but we can definitely improve that by feeding more data sets into our machine. That way, having this more data, it gives more to cross-examine and can be as accurate as possible with minimal to no false positives or false negatives. Though, as we have said before, false negatives are a lot more important to eliminate because telling someone that they don't have heart disease may lead to that getting worse without them getting checked out.
And here's our team. So for our project, we all worked on different parts of the project. We all did the data science together, and you can see we just a data analyst. We had some front end and back end teams, and we have Evan here, who was a master camper.
So for our actual predictor, we set up a form such you'd be able to put in both your age and sex to see if you'd get or have heart disease. And that's basically our entire project so far.